Okay, we're going to review operations with polynomials. Um, the first operation is going to be addition. So there's an example of the addition of two polynomials. What we do in this case is simply put like terms together. So there's only a x squared in this polynomial. There's no x squared here. So when we add them together, we end up with, of course, just 3x squared initially. There are 7x's here, and we're going to add 2x's. So that is going to make up 9x's. And then there is 5 plus negative 9. So that means we're going to end up with minus 4. And that's it. That's how we add two polynomials. How do we subtract two polynomials? Simply, let's have the same exact polynomials. Just remember to distribute the negative over the polynomial we are subtracting. So again, this is equal to 3x squared. 7x minus 2x is positive 5x. And then 5 minus negative 9, that is really plus 9 because of the double negative. Don't forget to distribute the negative. Will make 14. And that's it. How do we multiply polynomials? So let's say we want to multiply 3x squared plus 7x plus 5 by 2x minus 9. So no symbol between the two polynomials means we are going to multiply the two polynomials. So we multiply 3x squared with this and that is going to give us 6x cubed. 3x squared times 2x is 6x cubed. And then 3x squared times negative 9, that is negative 27x squared. All right, so we're finished multiplying this with those two terms. Now we multiply 7x times those two terms. So 7x times 2x will be 14x squared. And then 7x times negative 9, negative 63x. Finally, we multiply the 5 with those two, giving us 10x minus 45. I'm going to try to put a 45 here. And now we consolidate this by putting together like terms again. So we have minus, those two together make 13 negative x squared. Those two, negative 53 x, and the negative 45. And that's how we multiply, that is the product of those two. Division is the trickiest one. So example 4, let's say we want to write the fraction 6x cubed minus 13x squared minus 60x minus 50. Divide that by 2x minus 9. And we want to rewrite this as a polynomial with a fraction that is a proper fraction. This is not a proper fraction in the sense that the polynomial on the numerator is way bigger. Please remember, the size of a polynomial is measured by its highest exponent. So the highest exponent of this polynomial is 3. So the size of this polynomial is 3. It has degree 3. The size of this polynomial is 1, has degree 1. And consequently, this polynomial is way larger than this one. The size has nothing to do with the number, the coefficient. It has to do with the exponent. So this is an improper fraction in the sense that the polynomial on top is way bigger than the polynomial in the bottom. And so we want to change that into a polynomial, into a mixed polynomial, I suppose, or a mixed fraction in which we have a polynomial plus a proper polynomial. Okay, so we're going to put an equal, and we're going to leave this blank for now because we're going to perform the computations down here. So we're going to have 6x cubed minus 13x squared minus 60x minus 50, and we're going to divide this by 2x minus 9. So first we focus on the 6x cubed and the 2x. So 2x times what gives us 6x cubed, and of course we need a 3x squared. And then we multiply through. 3x squared times 2x is going to give us 6x cubed. Multiply this by the negative 9, and that is going to give us negative 27x squared. All right, and then we subtract this new polynomial from the original polynomial. So 6x cubed minus 6x cubed is no x cubed. Negative 13, now this is tricky because there's going to be this extra negative to worry about. So negative 13 plus 27 is positive 14x squared. And then what I do is bring down the rest of the terms so I don't forget them. All right, so now we start all over. What multiplied with 2x gives us 14x squared? Well, that's gonna be 7x plus 7x. 7x times 2x is 14x squared. That's what we wanted. We wanted to match this term. So when we subtract, this term goes away, and the polynomial that is left over is smaller. But then there's a consequence of this. 7x times negative 9, that is going to give us negative 63x. All right, and then we subtract this polynomial as we did in the previous line. And that's going to be no x squared, which is what we wanted. Negative 60x plus 63 is going to give us 3x minus 50. I bring down the 50 so I don't forget it. And now this is going to be tricky because what number or what quantity multiplied with 2x gives us 3x? So we need, I guess 1.5 will do, but in algebra we use fractions more than decimals. So 3/2 is what we need to multiply by. That is something I was not expecting, but there's no problem with that. So 3/2 times 2x, well, the 2's simplify, so we end up with 3x, which is what we wanted. And then 3/2 times negative 9, whoa, that is negative 27/2. Negative 27/2. And remember, we're going to subtract this. Okay, 3x minus 3x is 0. 50, rather negative 50 plus 27/2. I'm going to do that here on this side. Negative 50, remember, is the same thing as negative 100/2. Because if you multiply by 2 and divide by 2, you end up with this. And then we're going to add, so this is a side computation. Yeah, I'm going to try to squeeze it in here. Plus 27 over 2. And of course, that is going to give us a negative number, 73 over 2. So instead of trying to do this here, I just did it on the side. And so this should be negative 73 over 2. Okay, so now we're ready to give the answer. The quotient of those two is equal, indeed, to 3x squared plus 7x plus 3 over 2. So that is a fraction, but that is still a coefficient of this new polynomial. And then we still have a leftover, which is the 73 over 2. 73 over 2 divided by still 2x minus 9. Yeah, this is the answer. Yeah. We should really simplify that. So I'm going to write the final answer on the next page. So 4, this is from previous page. And we have 6x cubed minus 13x squared. I'm copying the problem of just so that we have continuity when we write this down, 2x minus 9. So that is equal. Otherwise, if I just put down equal, where does the other part of the equal come from? So I have to start all over here. We cannot just have an equal floating on the page without having another side of the equal. Anyway, so this is 3x squared again, as we have written before, plus 7x plus 3 over 2. That is not a problem. The only thing here is that we have a fraction within a fraction, and we really want to simplify this. We want to avoid this situation of a fraction within a fraction. So we can put the 73 in the numerator and then make the 2 part of this denominator. So we can put 4x minus 18, or we can put 2 times. So 4x minus 18 will do. So this is what I would call an acceptable simplified answer for this quotient, or I would also accept things like 73 over, and then the 2 times the original 2x minus 9. It is not necessarily clear which one is simpler. It depends on what the instructions of the particular problem say. Yep. Practice division. Division is a little tricky, and there are some cases that are a little more tricky than others. So for instance, if this polynomial was missing a square, then when you do your long division, this is called long division, you want to put a 0x squared because you want to have a column for the x squareds, because you may need that column in your computations. But this is a computation kind of thing. In the next video, we're going to do factoring, which is going to be the opposite of multiplying. In example 3, we multiply two polynomials, and then we're going to do the opposite in factoring, which is given this polynomial, how can we come up with that one? And that is not easy. That takes some practice. All right, this is a quick review of operations with polynomials, and we'll stop the video now.